Look at these exam stats. Pretty standard, right?
Mean 10, median 15, mode 20. On paper, it's simple, but mathematically, something is way off. How many students do you think it takes to actually make this possible? You're probably thinking 3 or 5. It's a fair guess. But the real answer is so large, it contradicts our intuition. Let's break down the logic. Most people try to solve this with 3 or 5 students. Spoiler, it's impossible. Start with 3. If the median is 15, that goes right in the middle. To have a unique mode of 20, we need at least 2 of them. But look, if we have 2 20s, the median jumps to 20. The rules break. The constraints are fighting each other. 3 is a dead end. What about 5 students? Same logic, median 15 and at least 2 20s. A mean of 10 for 5 students gives us a maximum sum of 50. But these 3 alone already add up to 55. The last 2 students would need negative scores to fix the average. It's not happening. Unless we assign negative values, 5 is impossible. The mean is just a balance point. If we want it at 10, the pivot sits right here. Everything else has to cancel out. But our constraints of 15 and 2 20s are greater than 10. They contribute a large positive deviation. To fix this, we need to counterbalance. We use a group of 1s on the far left to offset that positive deviation. This is why small lists fail. You need enough values on the left to counter those high values on the right. All right, we've got our targets. Let's see how many numbers we can fit into this list without breaking the rules. To keep the average low at 10, we need our values to stay small. We'll start with 1s. They are the minimum. Then there's the mode, 20. We don't know the count yet, so let's just say it shows up m times. But 20 is the unique mode. No other number can match that count, so the 1s are capped at m-1. Let's test 17. We're going to build this set using the smallest values possible. If the sum still exceeds 170, we know 17 is impossible. To keep the right side sum as low as possible, we use the smallest integers allowed, 15s and 16s. On the left, we use 1s, 2s, and 3s. We need some variety here so we don't accidentally create a second mode. Finally, we add the median of 15 to the total. The total is 172. Our target is 170. Even with the minimum values, the sum is too high. 17 is impossible. 19 looks like a candidate. We finally hit that 190 target sum. Median's 15, sum's 190. On paper, this is exactly what we wanted. But here's the problem. We're about to violate the unique mode rule. Look at the counts. We have 5 15s and 5 20s. It's equal. Without a unique mode, this entire set is invalid. Try to nudge a value to fix it. Now the sum is 191. The sum is too high. 21. This is the minimum, the absolute smallest group that satisfies the conditions. To average 10 with 21 students, our total sum has to be exactly 210. Check the mode. We have 6 students at 20, which narrowly beats the 5 students at 15, so 20 is the unique mode. The lower scores compensate for the high mode. The numbers, 15 from the bottom 10, 15 from the median, and 180 from the top group. That lands us right on 210. Divide 210 by 21 and you get a mean of 10. It's clean, it's rigorous, and it's the absolute limit. We have our solution. If you want to see the logic underneath more problems like this, hit subscribe. I'll see you in the next lesson.